All right, tomorrow's quiz, like I said, is 10 questions. I expect to see work shown. I'm not going to answer questions tomorrow of, is this the right way to do it? Am I on the right track? That's what the quiz is for, to let me know if you guys are on the right track or not, okay? You're going to have all sorts of different problems. Anything that we've talked about in any of our lectures, so you can look back at class videos, any homework stuff that you guys have seen, anything on this review, you need to be familiar with. So when you have anything like number 1, 2, 3, when it involves radicals, right? We want to break the radical down. You want to try to simplify as much as possible. If you can combine them all together to one answer, that's great. If there's 2 terms in your answer, that's fine as well. My suggestion to you is when you guys get something like number 1, I would start with the smaller number. Which one is smaller, 125 or 45? 45. So I would try to break down 45. What is a perfect square and a non-perfect square that's in 45? 9 and 5. I agree. So 9 times 5. That kind of gives you a hint of what the other radical might look like. Can you break down 125 and something times 5? Yeah. What? 25 times 5. All right, a lot of times that'll help you. If you start with a smaller number and break it down, that kind of gives you a guide of where to look. So now as we simplify, what is the square root of 25? So this comes outside. I have 5 root 5 minus what? 3 root 5, because the square root of 9 is 3. So you have 3 root 5. And now that they have the same common radical, the same quote-unquote last name, I can say 5 of them minus 3 of them gives me 2 of them. So it's 2 root 5, and that's your answer. You don't multiply 2 times 5 and get square root of 10 or anything like that. It's 2 on the outside, root 5 on the inside. All right, with me? Okay, let's look at the next one. Again, same thing. Which number is smaller? 18. So we have 1 and 18, 2 and 9, 3 and 6. Which one of those is a perfect square? 2. Right, 9 is. So I'm going to break this down into 9 times 2. So let's talk about 32. If you divide 32 by 2, what do you get? 16. Is that a perfect square? So 16 times 2. So as we simplify, the square root of 16 is 4. So I have 4 root 2. Wait, that looks like the 4th root. Plus what? 3 root 2. So now they have a common radical. If I have 4 of something and then 3 of something, I have how many of somethings? 7 square root of 2. Questions? Everybody okay? When we add and subtract, we're breaking down our radicals. All right, this one kind of threw some of us a little yesterday, which is totally fine. This is a tad bit different because your index isn't 2 anymore. That little number out in front isn't 2. It's a what? 3. It's a 3. So when we have letters, right, with a cube root, that tells you how many has to be in a group before you can pull one group out. So I'm going to rewrite this as the cube root of 4x's. Then I have plus the cube root of 8x. Everybody with me? So if I have just letters, I'm going to say, okay, I have to have, since the index is 3, I have to have 3 letters in a group before I can pull that one group out. So I'm going to take out this one group, and I have one group of 3s, and then I'm left with the cube root of x plus, is there a cube root to 8? Is there a number times itself 3 times? That'll give me 8.
Yes.
2. Good. So I can bring that outside, and then I'm left with the cube root of x. Do I now have a common radical? Yes. Can I combine this anymore, though?
No.
Why not?
Because the 2 doesn't have an x to it.
Correct. That's like saying x plus 2y. Would you guys combine that anymore? You tell me, no, you can't do that because they don't have the same letters or something like that. Or if I said x plus 2, if I just left it like that, can you combine that? No, because they don't have the same like terms. Meaning, like, you can't put a 2 and an x together because when you push them together, it becomes multiplication. So this right here would be your simplified answer to this question. Tons. All right, moving along. How is this one What do we do? How do we even begin this problem? Tell me. Distribute what? The 2 where? To everything. It goes to the letters and the numbers, right? So this goes here, here, and here. Should you guys try and do all of this in one step and just skip steps? No, you should not. All right? I'm going to rewrite this as 8 squared, and then I have x to the what? 8 or 12?
12.
Why is it 12? Good. Power to a power, 6 times 2. We multiply. And then I have b, that's a b, to the what? -6. Okay, I have 2 things that need to be simplified. What are those 2 things? The 8 squared, and then that b. All right, so I'm going to say 8 squared is 64, x to the 12th. How do I simplify that b to the -6? We put it in the denominator. You cannot have a simplified answer that has negative exponents. If we are negative in the numerator for the exponent, guys, not a number. Like if that was -8, it would stay in the numerator. If your exponent is negative, you bring it to the denominator. If it's in the denominator and the exponent's negative, you bring it to the numerator. Everybody with me? Okay. Scooting along. Everybody's favorite. Yesterday, there's like 3 of you that even tried this one. You will have something like this on your quiz. Just one. But it's not bad if you take your time. If you try and do everything in one little tiny space next to it, yes, it's going to be an issue. But all you need to do is take each thing step by step. So I'm going to take this 4 and I'm going to distribute it to every single thing in this numerator and denominator. It's a lot going on. I'm going to suggest to you that you leave your numbers, your coefficients, in parentheses. So I'm going to write this as -3 to the 4th power. Guys, is the exponent negative? No. So do I move this down to the denominator, make it positive? No, it doesn't work like that. So I have x to the what? 7 times 4 is 28. Great. Y to the -8. Now some of you are like, well, that has to go down. I wouldn't do it right now. Just do everything step by step. And then z to the 20th. Good. Over, I have 2 to the 4th power. X to the 32nd, 32. Y to the 36, good. And z to the -16, good. All right. Step by step, it's going to get a little smaller. -3 times -3 is 9 times -3 is -27 times a -3 is positive 81. Okay, that's taken care of. I have x to the 28th. That's positive. Does it need to move anywhere? So I'm going to leave it right there. I have y to the -8th. How do I make it positive? Ooh. I'm going to move it to the denominator, so it becomes like that. And then I have z to the 20th. Does it need to move anywhere? No. Okay, good. So I'm going to cross that out because I already dealt with it. I dealt with that one. I dealt with that one. So let's move to the denominator. What's 2 times 2?
4.
Times 2? Times 2?
16.
Okay. Done. X to the 32nd. That's positive, right? So it can just stay. Y to the 36. Is that positive? So it can just stay. Z to the -16th. Where do I move it so it becomes positive? I move it up top. Now, that's how I like to solve these problems. I don't like to deal with negative exponents. If you guys don't mind and you don't mind saying -16 minus 36 and then moving stuff all over it, that's totally up to you. I just like to deal with things when they're all positive. So now you don't have anything. 81 and 16 don't simplify, so you can just leave them. 81 over 16, that's fine. 81 in the numerator, 16 in the denominator. Now I have 28 x's on top and 32 on the bottom. Where is your exponent bigger? On the bottom. So when you subtract, that's where your letter is going to stay. Does that make sense? You're saying 28 minus 32. What's 28 minus 32? It's -4, right? This would be x to the -4. But you just told me, where would the x's be? If I have x to the -4th, where would I put it to make it positive? On the bottom, right? If you need to, guys, write out 28 x's on top and 32 on the bottom. Cross out 28 of them, and you'll see that 4 are left on the bottom. If you have to do that, do that. Who cares? But I've already dealt with this. I dealt with this. I dealt with this. Now I have z to the 20th times z to the 16th. When I have the same bases and I'm multiplying, what do I do to their exponents? So I have z to the 36. Good, on top. I have the same bases on the bottom, y's. What do I do to their exponents? Add them. I have y to the, how much? 44. There you go. That's it. What is anything raised to the 0 power? Okay. I'll do an extra problem like that at the end.
I have a question.
Uh-huh.
When you switch it, does it matter if you put it like left or right? If it's the same letter?
No. Good question. No. All right. I had a couple of you yesterday come up to me and say, what in the world? Neither of these are perfect squares. I know that. But a house times a house is a bigger house. 15 times 3 is 45. Is there anything in 45 that is a perfect square and a non-perfect square? What? 9 and 5. So 9 times 5. The square root of 9 is, so it's 3 root 5. Guys, don't complicate problems if you don't have to. That problem is as easy. A house times a house is a bigger house. Yeah. A house times a house is a bigger house. If we move on to number 7, where's 7? Moving along. All right, 10 and 30. Okay, I can't break either of those down, but I can put them together, right? 10 times 30 gives me the square root of 300. Is there a perfect square and a non-perfect square in 300? What is it? 100 times 3. What is the square root of 100? So this is 10 root 3. Questions? Everybody okay so far? All right. Not bad, not bad. All right. Now this is it's a totally different concept. This is multiplication, right?
No.
Wait, how do you know? The subtraction sign. Okay, so tomorrow when you guys get this, and some of you start going like this, and then how do I distribute that negative? When you come up to me and be like, am I doing this right? I'm going to say, I don't know. All right, you have to understand when parentheses are stuck next to each other and there's nothing in between, that's multiplication. This is not multiplication. This is saying 2x squared minus 5x minus this whole expression here. So you're going to take this -1 and you're going to distribute it to everything in the second parenthesis. So your first parenthesis stays exactly the same, 2x squared minus 5x. Now I have a -1 times x squared is minus x squared. -1 times -8 is positive 8x. And -1 times 3 is minus 3. Once you get that distribution done, now this is just combining like terms. So we start with the biggest exponent. The biggest exponent I have is x squared. I would circle it so you make sure that the sign in front of the term stays with it. What's 2x squared minus 1x squared? X squared. Good. That's done. You don't have to look at it anymore. What's a -5x and a positive 8x? What kind of 3? Positive 3. Good. And then what? -3. Perfect. Is that in standard form? Yes. What is the leading coefficient? 1. It's not 1x squared. It's just the number in front of the variable with the highest exponent. What is your constant? -3. Good. What's the degree? 2. Perfect. Good job, guys. Question? For the quiz? Yeah. All right, another multiplication problem?
No.
No, because there's a what? Right here, that number at the end that doesn't have a variable, that's your constant. Yep. Guys, don't you dare be afraid to raise your hand and ask a question. Don't be hesitant. If it's a question I've answered 900 times, that's fine. I've been teaching 20 years. I answer the same question all the time. I'll get a question tomorrow. Some of you will come in and be like, there's a quiz today? And I'll just smile and say, yes, pumpkin, there is. It's fine. It's totally fine. All right, what's going on here? Before I start combining all this stuff, what do I need to do first? Distribute that -1. So boom, boom, boom. First parenthesis stays exactly the same. 5x cubed plus 4x squared minus 3x. Now we distribute. -1 times x is minus x squared. -1 times 7 is minus 7x. -1 times 2 is minus 2. Everybody with me? All right, biggest exponent you see is? The 3. Is there anything other than 5x cubed that has an x cubed? So I just rewrite 5x cubed. Now I have a 4x squared minus x squared. 4 minus 1 is? So plus 3x squared. It's good. Negative 3x and a negative 7x. Negative 10x. And then I have? Minus 2. Perfect. Bobby, what's the leading coefficient? Good. What is the degree? Perfect. What's the constant? There you go, bud. You got it, right? Perfect. All right, now we're adding. What's going on here? Why is this multiplication or distribution? Good. There's no sign. That negative 7x squared is just stuck next to the parenthesis. That means multiply. Stuck next to means multiply. So I'm going to say negative 7x squared times x. What is the variable on that x? A 1. When we have the same variables that we are multiplying, what do we do to their exponents? So I have negative 7x cubed. Perfect. And then I have what? Minus 21x squared. That's it, guys. I had 2 people email me last night. Can you check this? What did I do wrong? Nothing. Don't complicate things if you don't have to. Take something like this and be like, oh man, thanks so much. What's the leading coefficient? Negative 7. What's the degree? What's the constant?
None.
Good. You can either say none or you can say 0. Because there is no number right here that is being added or subtracted that doesn't have an x or anything to it, just no random number. So your constant, your answer for that for a constant would be either 0 or none. Everybody with me? All right, scooting along. This problem's a little more complicated. What would you guys do first here? Tell me.
Distribute the y.
Yep, we have to distribute. We've got to multiply first before we can start adding things. So there's just 2 distributions we have to do here. Y to the first times y to the second gives me y to the third. And then y times negative 9 is negative 9y. Right? Okay, plus 3y squared times 2y. 6y cubed, good. And then 3y squared times negative 1 minus 3y squared. Perfect. Are we done? No. Combine like terms. I have 1y cubed and 6y cubes gives me 7y cubes. Then I put minus 9y.
That's a 2.
Why not? That is a 2. It should be a 3. I was thinking about what I was asking next.
What's 2 or 3?
That's a 3. So now I write minus 9y?
No,
Why not?
because there's a y squared.
Because there's a y squared. Don't just go in order, guys, of what you see. Go highest to lowest exponent. So it's y cubed. Then I have minus 3y squared. Then minus 9y. What's the constant? 0 or none. Good. What is the degree? 3. What is the leading coefficient? 7. You guys are going to get that question right for sure. What are we doing here? Just foiling. First times first. If you don't remember what FOIL stands for, that's okay. Take the first term and distribute it. 3 times 7 is 21. X times x is x squared. Take the first term and distribute it here. 3 times negative 4 is negative 12. Then I put my x. Now we take our second term and distribute it. Negative 2 times 7x is minus 14x. And then a negative 2 and a negative 4 is plus 8. Negative times a negative is a positive. Combine like terms in the middle here, guys. 21x squared minus 26x plus what? Good job. Constant. 8. Leading coefficient. Degree. Yay. Everything on this page done? Okay. Sam, scroll to the next page. I'm just giving you a hard time. All right, I added 3 problems here. I'm actually going to add one more, but it's for your own good. All right, this is, again, another multiplication problem. This one just gets a little yucky, like yesterday's did. But that's okay, guys. Just take your time. Take that first term of 2x cubed, and you're going to multiply it to everything in that second parenthesis. So 2x cubed times x squared gives me 2x to the 6th. Just kidding. 5th. We add. I was thinking to myself, don't multiply. So 2x to the 3rd times negative x is negative what? 2x to the 4th. 2x to the 3rd to 7 gives me plus 21 x cubed. Negative 5.
14.
Oh, golly. I'm sorry. I'm thinking in my mind cubed times 3. You know, totally my bad. I'm getting ahead of myself. 2 times 7 is what?
14.
Ay, 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 x cubed. It's only Wednesday, right? Ay, ay, ay. All right, now I take negative 5. Negative 5 times x squared. Negative 5x squared, good. Negative 5 times negative x. Negative times a negative is a positive, good. And then negative 5 times 7. All right, is there anything that has like terms here?
No.
Look at that. We just did all of that, and there's not one thing that has a common like term. That's okay. That is your answer. What's the constant? Negative 35. What's the leading coefficient? 2. What's the degree? 5. Good job, guys. Very good job. All right, this will be a question like this on your quiz. I've asked you all of these questions for almost all of the polynomials, so this should be a no-brainer for y'all. Just take your time. If we're going to write in standard form, we take the highest to the lowest exponent, yes? What's the highest exponent you see here? Okay, so it's negative 6x to the 5th. Remember, whatever sign is in front of the term stays with it. So then what do I have? Minus, good, negative 19x cubed. Then what? Plus 7x squared. Plus 3x minus 1. Now you guys can answer all these questions. What's the degree?
5.
Leading coefficient?
Negative.
Constant? Negative 1. Good. And again, if there was not a constant, we would write either 0 or none. Okay, these extra little ones are just for extra guidance, extra practice. This is a distribution problem, 15, yes? So, guys, just because there's extra letters and all that stuff, the rules stay the exact same. You multiply the coefficients, and if you have the same bases, you add variables. So, take your time. Negative 3 times 4 is negative 12. I have, this is x to the first and y to the first. So, I have x to the 6th and y to the what? 3rd. Perfect. So then you just scoot along. You do the same thing. Negative 3 times negative 6 is positive 18. And then I have x to the what? 8th. Y to the 4th. Good. Now I take this way out here. I have negative 3 times negative 9 is positive 27. Good. X to the 12th. Y to the 6th. Right? That's it. There's nothing to combine. There's no x and y that both have the exact same exponential value. Don't worry about, oh, is this in standard form? Don't worry about that. When you have a combination of variables, just leave it how you write it. Questions? All right, 16 is just another big multiplication problem. Do the exact same thing we just did. Multiply variables. When we multiply variables with the same base, we add exponents. Multiply coefficients. So I'm going to take this 4 times -1 gives me -4. I get x to the 4th, y to the 6th, correct? Because this is to the first power and this is to the first power. So now I'm going to take 4 here. What's 4 times 3? 12. X to the 10th. Y to the, what? What's 5 plus 9? 14, good. Now I take 4 and I go here. So 4 times -10 is -40. X to the 5th, y to the 16th. Yeah? Okay, so now we're going to do the exact same thing with the second term. -8, x, y to the 4th. Negative times a negative is a positive, so I have 8, x to the 2nd, y to the 5th. We add our exponents. -8 times 3 is -24, x to the 8th, y to the 13th, good. And now -8 times -10 is plus 80, x to the 3rd, y to the 15th. Perfect. There is nothing that has the exact same exponential value for x and y, so that's it. If I were to ask you, which I'm not, if I were to ask you what degree this polynomial was to, how would you figure that out? You add. You add each set of exponents. So like this right here would be 10. This one would be 24. This is what? 21. This is 7. This is 21. Good. And this is 18. So what degree is this to? The 24th, because it's the biggest number. But I'm not going to ask you that. All right. What does 17 mean? Do I just take this 3 and I put it here and here? No. Do not do that. What does this mean? -3x plus 5 quantity cubed. It means you have how many -3x plus 5s? 3. So all you do is you write -3x plus 5 times -3x plus 5 times what? -3x plus 5. You're just foiling. That's it. Leave the first parenthesis alone. What's up?
How do you know when it's quantity? Obviously, you can tell like that it would seem like it, but like, is there like a way to tell, or you just kind of?
If you have a parenthesis that's raised to an exponent, that means you have that many parentheses.
No, yeah. How do you know not to like distribute?
Because that's a good question. How do you know not to distribute the exponent like we did before? Because there's a plus sign. If there's a, God bless you, if there's a plus or a minus sign, this plus sign holds these two together like one thing. If you just have a bunch of stuff multiplied, then yes, you just go boom, 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 boom. But if you have a plus sign in the middle of two terms or a minus sign, that means that whole thing, however many times you have the exponent.
Oh, just like if there was a plus right here.
Yep, correct. All right, so now we're going to multiply. What's -3x times -3x? 9x squared. -3x times 5 is minus 15x, right? 5 and -3x is minus 15x. 5 times 5 is 25. Now, I just made this problem up before you guys came in here, so this number is going to get a little bigger than I anticipated. Just work with me. So we have -3x plus 5. And then when I combine like terms, I have 9x squared minus 30x plus 25. Now, all we do is multiply again. You're going to FOIL. I'm going to say first times first. So -3 times 9 is -27. I have x cubed, correct? -3 times -30 is plus 90, and then I have x squared. And then negative 3 times 25 is minus 75x. Now we take the 5. We do the same thing. 5 times 9 is plus 45x squared. 5 and negative 30 is minus 150. Right? X. And then 5 times 25 is 125. And now we just combine like terms. Is there anything that has an x cubed other than minus negative 27? No. So I'm going to just rewrite that. Negative 27x cubed. Anything with x squareds? Yes. 90 and 45? What's 90 plus 45? So plus 135 x squared. I have a negative 75 and a negative 150. Gives me, think money, negative 225, good. Negative 225 x, and then what? Plus 125. That's it. Now, let me repeat the question that was just asked. Well, let me do the next problem, and then I'll repeat the question, because that was a very good question. All right, so when I first wrote this problem, you guys were like, what in the... Why is this not as awful as it seems? That first parenthesis is raised to the 0 power, and anything raised to the 0 power is 1. If I took this 0, I would have to go here, 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 and here. Okay, so this answers the question that just arose. Why do we distribute here, but here we didn't distribute the 3? Do you guys notice that in number 18, there is not one plus or minus sign in between any of those terms? If there's a plus or minus sign, that means, ooh, take this whole quantity that's in this parenthesis and write it out however many times it says. Since there is no plus or minus sign, then each thing is considered by itself. So all of these raised to the 0 power, you guys can literally go like this and write what? 1. So then I come over here and I just worry about this. What do I do with this 2? I distribute it to absolutely everything. And then I'm just going to simplify. So I have negative 2 to the 2nd power. Do I put that in a denominator and it becomes positive 2? No. That only works for negative exponents, not for negative numbers. So now I have x to the 8th, because the power to a power we multiply. Y to the 18th. And z to the negative 32nd. So there's 2 things that I have to simplify. What's the first thing? So negative 2 squared is? Positive 4. X to the 8th stays in the numerator because it's positive already. The exponent is positive. Y to the 18th stays in the numerator. Where does z to the negative 32 go so it becomes positive? To the denominator. Good. And there you go. When you guys simplify, you should not have any negative exponents. 0.
So when you distribute it,
Talk to me.
when you distribute it, you only do like times on the exponents, and then
You multiply the exponents because it's a power raised to a power. Stan, make sure you sign out.